Okay, so continuing with the test through review, going with 2D, starting with 2D. So given this drawing, trying to find the z-score, this is from section 5.3. So we have the area shaded to the left of here of 0.0129. Based on where the z-score is, it should be negative, and this is one of the easier ones because the area to the left is actually what we need to look up in the table. So going to the negative z side of the table, again, searching through the areas, we're looking for an exact match. Here at 0.0129, and it's negative 2.2 and then 300. So my z-score is negative 2.23. Going to 2E. So given this one's a little harder than we normally do, so this is a more challenging one. I generally don't give a problem like this on the test. It was in an old book, so that we don't use anymore, but let's go through it because it's a nice challenge to look at anyway. So we've got two z-scores, shaded area here. This is 0.3907, that's shaded on the left. On the right is 0.2794. Okay, so to find the z, and they're not going to match because the area, they're not going to be the same z-score, positive and negative, because we have different areas shaded. If they were the same area, we could use the idea of symmetry. So what we're going to do is we're going to take the idea that on the left side we have an area of 50% or 0.5. And again, if we look up 0.00 on the positive or negative z side, we get the area to the left. So to get the left z-score, we're going to take 0.5 or 0.5000 minus the unshaded 0.3907. Subtract. That's going to give me the area in the left tail, which is going to be 0.1093. So this area here is 0.1093. And we're going to look for that on the negative z side of the table, because that's where we are here at 0.1093. And we're going to find it here at negative 1.2 and 300ths if we look up. So that on the negative z side, our z-score is negative 1.23. So that's half of our answer there. So then for the positive z-score, we're going to have to take the total amount of areas that we've got to the left. So I'm going to put in this one we just found, 0.1093. I have to take this plus this plus this, add them all together. 0.1093 plus 0.3907 plus 0.2794. Definitely cannot do that in my head. Let me add those up. So 0.1093 plus 0.3907 plus 0.2794 gives me a total area of 0.7794. So let me pick another color here. Let me pick brown. So all of this area from the left tail all the way over to Z is 0.7794. If we want to find that z-score, that's what we have to look up. And we're going to find that on the positive z side, because we are on the positive z side. So again, we're looking through the z table, and we are looking for 0.7794 in the progressively larger numbers here. And so here we find it at 0.7 and 700ths, 0.7794. So Z is 0.77. That would be the other z-score. Sorry, I rubbed this off a little bit. Okay, so there's my other answer for the other z-score. And finally, for 2F, we've got this drawn. We've got a z to the left of the mean, which means it's negative. The shaded area falls to the right. And this shaded area in total is 0.9082. That is not what you want to look up. You'll never want to look up the area to the right. You need the area to the left in order to find the z-score. So we have to use the idea that the entire area under the curve is 1, and to get the left tail, take 1 minus 0.9082, which is going to give me 0.0918. That's what I want to look up, 0.0918 on the negative z side, because that's where we are. And I should find an exact match for that area of 0.0918. Here we go, at negative 1.3, and if we look up, and if we look up and 300ths. So negative 1.33 will be my z-score. Okay, so going to number 3. And number 3, again, we're using from section 5.3. We're going to give an area. We're looking up to find z-scores. So that's, and again, that's section 5.3. So it says the middle 60%. So when you get percent, you're getting area, and it's telling you where by saying the middle lies between what two z values. So I'm going to draw the picture. Standard normal distribution, the mean is 0. So the middle 60% you have to split equally between each side of our symmetric curve here. So z here and z here, and this should be maybe not drawn so well. This is 30%, and this is 30% because that's 60%. But what you really need to know is what's in each tail, specifically the left tail. So remember, the total area is 100%. So if we take away the 60%, we've got 40% left, but we've got to split it on each side. So that means this left tail is 20% and the right tail is 20%, which makes 100% total, 50% on each side. If we want to know a z-score, the best one to look up is the left tail. So I'm going to change my 20% to a decimal, 0.20, and I'm going to add some more zeros because in our table, area has 4 decimal places. And where are we going to find that? On the negative z side. So we're hoping to find an exact match at 0.2000, but we're not going to find an exact match. So we have to find the closest two areas in the table. So, and again, so we're going through these areas. The first 0.2 something is 0.2005. That's a little too big. We want 0.2000. So we look to the left. 0.1977, that's too small. Is one closer than the other one to 0.2000? You could subtract in your calculator. This one's closer. 0.2005 is closer to 0.2000 than 0.1977. So we're going to use negative 0.8 and, let me pull this down, negative 0.8 and 400ths. So negative 0.84 is my negative z-score over here. But remember, we want both, and because of symmetry they match, so this is positive 0.84, which probably in the answer key I wrote it as plus or minus 0.84 since it covers both answers that way. Okay, so if we now go to question 4. Question 4 says, find the area under the normal curve that lies between the z values of negative 3.0 and positive 3.00. So let's draw the picture. Negative 3.00 is negative, so you lie to the left of the mean, very far to the left. And positive 3.00 is positive, so to the right of the mean, very far to the right. And we want the area between. So there are actually a couple of different ways to do this problem that both give you the same answer, so your choice and how you want to do that. If I look up negative 3.00 on the negative z side, my z-score now I'm looking at. So row negative 3.0 and then down to 0 hundredths, I get this area 0.0013, which is the area to the left, in the left tail. 0.0013. So because of symmetry, I know that the right tail is the same, 0.0013. So one way to do this is to use the idea that the entire area under the curve is 1. And to get the shaded area, take 1 minus 0.0013 on the left tail, minus the 0.0013 from the right tail, which is going to give you 0.9974 as our area, 0.9974. So that's one way to do this problem. The second way to do this problem, and either way is fine, they both give you the exact same answer, is to take the mean of 0 and again draw in my negative 3.00 to the left of the mean and positive 3.00 to the right of the mean, and it said between to shade. So again, if I look up negative 3.00 as I just did earlier, I get the area in the left tail, 0.0013. Now, if I go to the positive z side and I look up positive 3.00 on the positive z table, here, 3.0, and then pull this down, and then 0 hundredths, I get 3.00, I get 0.9987. That is the area to the left. 0.9987, all the way to the left tail. So to get the shaded area, I take 0.9987, taking away the unshaded left tail, 0.0013, which is going to give me 0.9974. Exactly the same answer I just got by doing this problem for a different way. So either way is good. Okay, on to question number 5. Okay, so in question 5, it says, find the standard z value such as the area above the mean and below z. So this is kind of just telling you where things are. So the area above the mean means to the right of the mean, and below z means to the left of z. So we're just talking about this area here that's above or to the right of the mean, and below z is an area of 0.4788. Now, if I want to know this z-score, again, I need to know the area to the left. So I have to realize that the entire left side is 0.5 or 0.5000 by knowing it's 50% or by looking up 0.00. So the total area to the left of z, I have to add the 0.5 plus the 0.4788 that was given, which gives me 0.9788. That's what I have to look up on the positive z side, that area. So this is from section, again, 5.3. I'm looking for 0.9788. And where I'm going to find that here is in row 2.0, and if you look up, and 300. So 2.03 is the z-score that gives us that answer. Okay, so time for one more. Okay, so number 6 says find the standard z value such that the area below the mean, that means to the left of the mean, and above z, that means to the right of z. So this area here is what's being given. Below the mean, to the left of the mean, and above z is 0.3212. So if I want to know the z-score, I do not look up 0.3212. I need to know the area to the left in the left tail. So once again, we're going to use the idea. You can either look up the 0.00 and get the area to the left of 0.5000, or know that the whole left side is 50%. I'm going to subtract 0.5 or 0.5000 minus 0.3212, which is going to give me 0.1788, I believe. Hopefully my math is right, doing that in my head. And I'm going to find that on the negative z side. I'm looking for 0.1788 as an area. And I'm going to find that here at row negative 0.9, and if I look up, and 2 hundredths. So negative 0.92 is going to be my z-score. Okay, so I'm going to stop here, and I'm going to start my next video with number 7.